thanks everyone for being here. And certainly this is a very special time at the conjunction of new platforms and new eras. And for us as a company that started almost 8 years ago and has had a sort of singular focus on trying to bring one of mankind's most profound evolutionary tools, which are our hands and fingers, and the fact that we have evolved as humans, and even if dolphins were actually a lot smarter than us, they wouldn't be able to do a lot with that intelligence because they don't have the evolved ability to connect with their environment, to communicate with their environment in these miraculously, magically subtle ways that are our hands and fingers. And that's why we've been so singularly focused on such an important issue, because we live in a world where every single person has things embedded in their thermostat that are probably orders of magnitude more powerful than a entire building full of supercomputers might have been years ago. But at the same time, how we interact with things has not really kept pace. We have iPhones that have more power and can do more calculations in a second than we can in our entire lives, but the extent of how we actually tell them what we want is still mostly, am I touching, am I not touching? And if you look at how technology has progressed, you see this very linear curve in terms of interaction as you compare interaction to the actual power of computing from an underlying perspective. So we think right now that these different platforms are at this critical stage where we have devices like virtual reality, we have devices like augmented reality, and billions of dollars are being spent by companies to solve hardware problems. But there is a fundamental missing link, which is the ability to provide something that both is instantly accessible, that can actually achieve the necessary results of all of that investment, which is something that mainstream people can pick up and use, which is a high threshold. People need to almost instantly, truly within seconds, maybe less than a second, understand at least a little bit about how to use the system. And that's impossible with anything like a game controller. It's impossible with anything, even excluding all the economic reasons, excluding all of the practical reasons why having large controllers and trackers around rooms are impractical. Even with the best emulation of a hand, it is not a hand. And that fact creates a massive barrier to the instantaneous accessibility and the universality that are hands, because with this problem is also the potential for a solution, which is that if we can solve this problem and we can bring true finger-level tracking with ultra-low latency that can be embedded in every VR AR device, every mixed reality device, that can be ubiquitous, then we enable not just sophisticated technologists, but also a 80-year-old grandmother to instantly use her hands, but also not even we're able to escape even cultural restrictions, even linguistic restrictions, because there is no difference. Our hands are so powerful, that evolution is so powerful. This is such an important part of our humanity that it transcends culture, it transcends language. It is not as if people in Madagascar use their hands differently. It's not as if people in China use their hands differently. So if you can create a paradigm that is physical, that is at least skeuomorphic enough to feel like it is bringing a connection with the physical world. And so this is something we've now been spending a lot of time and energy on. And incredible associates of ours like Kichi Matsuda in London have been working with teams to try to investigate what the right balance between three-dimensionality, skeuomorphism, but also and accessibility is, because we think now that our hand tracking finally, after working on it for truly 7 or 8 years and hundreds of millions of dollars later, is at a level, and we're seeing that as a technology, hand tracking is going to be able to cross the threshold where it will be able to be embedded ubiquitously in devices for a few dollars per unit eventually. And so the next question is, how do you actually execute on implementing this in things? And how do you implement it in a correct way that makes it, that uses the fundamental power of hands to increase accessibility and increase bandwidth rather than doing it in a bad way, which can decrease bandwidth? Because of course, you can't take it for granted that just having better technology or something that feels magical or cool or different is better. There are a lot of ways to use technology like this to make things worse. In fact, I would say that almost every attempt to use things like gestures are moving in a direction of making things worse. If you're going from a system of keyboard and mice and touchscreens to asking a user to learn an entirely new language, to learn a subset of sign language, that is not better, especially if it doesn't actually solve the problem of going beyond binary input. There is not that much difference between looking at a user to see if they have made a V sign with their fingers or looking to see if they've pushed X to close the window. So asking a user to learn a gesture to get to the same place they already have been for decades isn't better, even though it is using technology, even though it seems cool. And a lot of people in the industry think that that's enough. They want to stop there. And that's why we've invested so much in this research, because it isn't enough to just have the technology. It has to be used in a way that finds compromise between the fact that the technology has to actually be used for things, and it has to be used for many things. And we want it to be used by professionals who are doing 3D data visualization at scientific labs, but we also want it to be used by 10-year-olds who are learning physics for the first time, and we want them to use their hands to feel and learn in the same way that we learn as children when we throw a ball through a basket. And in order to make something that works for all of these people, you have to do a lot of experimentation, and you have to make sacrifices, because obviously, I think as we've seen with smartphones over the last decade, there has the introduction of a skeuomorphic interface initially was necessary for it to actually be mainstream. And I think that if you try to build something that is for a specific group, if you say, well, we can have a version of an iPhone that that isn't skeuomorphic, that's not direct, that's for power users, or something that has lots of gestures and sign language, you fundamentally never get off the ground, because the critical mass required for developers, the critical mass required to sort of overcome the chicken and egg problem that's necessary for these platforms to actually become ubiquitous is so massive that any attempt at anything other than something that can be instantly revolutionary, and making the sacrifices that come with that, sort of having the courage to focus on a set of experiences that are very, very powerful for some subset of users, but also instantly accessible, and create this first interaction set. So this research that we have been doing, it covers obviously many use cases. It is, there are use cases in training and maintenance and social things, and education, healthcare, entertainment. Certainly we envision a world where people are reaching out and they are, an airplane mechanic is repairing an airplane on the other side of the world with his fingers using a augmented reality device. And certainly I think that everyone here shares the same vision, obviously, since people are so passionate about this space. So, shares this vision about the possibilities of a world eventually where, whether it happens in 5 years or 10 years or 15 years, the fusion of unlimited augmented reality power, the ability to create things that are physically indistinguishable from reality, and fuse them together with interactions that are also indistinguishable from reality. That is, in a lot of ways, the end of a lot of our existing technology. It certainly makes all existing forms of technology unnecessary. You certainly don't need a TV anymore, or a phone anymore, if you can project things. But it also just changes the definition of space and time. It changes the definition of things like the nation state. It changes how we think about our communities. Like if I grow up and I can feel like I am physically in the same room as a friend in Australia, or even what does a room mean in a world where we can completely control our reality and our shared sense of presence with other people. And I guess as I use this word presence a lot, I think that is a minimum standard that we have not met yet as a community in these spaces that captures many things. It captures a sort of sense of actually being somewhere visually, but it also captures a sense of of at least a few other types of connection, of a physical connection, of a social connection. So the ambition for these types of platforms, whether it's virtual reality or augmented reality, I think is to actually make people feel that sense of true presence, not where we are now, which because of limitations of hardware and software, things like field of view, things like resolution, obviously we have not gotten to the point where the barrier between reality and virtual is hard to distinguish, but we have gotten to the point where people are starting to understand where that distinction is and starting to understand the power and the excitement and the potential of being able to bridge that barrier, which creates this extraordinary potential. And this is why we've spent a lot of time working on this next generation of taking these things, undergoing these experiments, thinking about how these objects exist in 3 dimensions, and then at the same time trying to capture them from the perspective of actually making it useful for other people. So we understand that if we believe that the way that people have to interact with 3D objects is in a way that is as similar to reality as possible, and if we sort of tout the idea that someone in Vietnam should be able to grab a ball and touch it the exact same way and have it perform exactly the same as they expect it to work as a human being, then that means not just that there can be one way, but that there have to be almost every possible physical way of touching that has to produce the desired effect, which is why we've spent the last year or 2 working on things like a interaction engine, which sits inside platforms like Unity and Unreal and tries to make it easy for developers to take a concept like a 3D object and then what is kind of the minimum necessary level to make the interaction actually cross that threshold of better, which is not that I, as a user, should ever be asked to try and fail to do something physical with an object. So I can't be told in a tutorial that in this app I have to use one finger to touch the ball. I can't be told that it didn't work if I tried to grab it like this. So all of these different thousands of, hundreds of thousands, millions of permutations of how we actually interact with things in subtle ways have to exist, which is an unreasonable thing to ask every developer to replicate. And even if everyone tried to replicate it, the replication itself would feel inconsistent. So we've made an effort to create the beginnings of a engine that can make this not only abstract it to make it easier for developers, but most importantly, to abstract it for the sake of consistency, to make it so that end users not only see their hands and fingers, but they see that the way their hands and fingers interact with physical space is consistent. And they can open applications and not have to think about, as they open the application, what the rules of the universe are going to be, how gravity is going to work, how physics is going to work, doesn't change from moment to moment in real life. And it also shouldn't change unless you want it to in virtual worlds or in a mainstream sort of 3D spatial operating environment. So I guess this is an example of something that is the right path for 90% of people, and certainly eventually being able to tweak physics and have, obviously there is incredible potential around creating your own sort of physical realities, and experimenting with physics and tweaking physics as a child to understand and explore concepts in a physical way. But first, we have to get to the point of consistency, and consistency, predictability in a visual way, in an interaction way, and use that as a bridge to get enough of a mainstream audience using VR and AR in ways that are actually useful to them, not just these dangerously validating experiences that all of us are guilty of, which is you can get a lot of satisfaction and you can raise money by making people feel like something is special and useful for minutes or an hour, but that is different than actually having something be better. And I think this space is now at a point of maturity where it needs to get to that next level. And fortunately, I think that we're seeing a coalescence of tools in terms of billions of dollars of investment in hardware, technology, optics, and we hope to play a role through interaction, and not just the physical or hand tracking side of the interaction, but also in terms of, and not just in terms of being this middleware layer for developers, but also in terms of our sort of experimentation and thought leadership, and not only releasing these examples to push boundaries, but also ourselves thinking about what are the best forms of software to create, and other ways of accelerating and expediting the development of these technologies. And so many of you may have heard of Project North Star, which we announced about a month ago. And this is one of the examples of something that we have done to accelerate the space, because I think, like many people, obviously there's a general problem with most types of hardware, but particularly with platforms like augmented reality, in the sense that you have to spend billions of dollars and create novel optics, and once you do that, after spending many years of doing it, companies can copy or replicate the technology in a short period of time. So that makes companies that already exist that are investing in this want to hold it back, and target having a huge launch with lots of content and having to have enough momentum. Thinking about publicly known companies like Magic Leap and the companies that we are working with to embed hands that are working on equally sophisticated attempts at AR in secret, but everyone understands that they can't just win through hardware. So for the enterprise user, for the for-profit community, there's a challenge. And obviously, we want the best AR technologies to exist as quickly as possible. And then there are problems for other types of users, for the sort of enthusiasts, for the open source community, because unlike software, where open source has conquered, hardware also requires billions of dollars. And so even though you may have the global talent of hardware engineers and people who can contribute, and certainly the ability and interest in solving these types of problems. There has not previously been a mechanism for that to be brought together in a way that can combine with the actual sort of the barriers that are physical or that are based in silicon, that are based in optics, that are based in long lead time components that have to be fabbed. So there's a short-term and a long-term, I guess, part of our thesis. And the very short-term part of our thesis is in doing our own experimentation to get to a ultra-wide field of view AR device, because we feel like right now many companies have made sacrifices in the interest of getting things into market that are not good enough even to create the basic experience or for people like Kichi in our lab or developers to experiment and actually feel what it would be like to use hands in an augmented reality environment. So the field of view has to be large enough that you can actually use your hands spatially to interact with it, and something that has a 50-degree field of view or a 60-degree field of view or even a 70-degree field of view or a 90-degree field of view doesn't work. So there's a big gap between where the for-profit sort of industrial applications are and where we think the space has to be. But at the same time, we don't want to wait 10 years for these cycles to fix themselves and for the first devices to emerge for developers and for ourselves to start to create things. Because having technology available in the world that people can access, use, demo, that can unlock incredible power, and it can make things happen a lot faster because we believe a lot in the power of emotion. So we've decided to open source Northstar, which is a project that, through some of our own investment, but also through the cooperation of some very large partners, large companies that are invested in this idea of commoditizing the hardware as quickly as possible, given that that is the natural end state of all hardware. So getting the best hardware, but making it commoditized. And companies, large camera module suppliers, large silicon suppliers, large lens suppliers who themselves accept and embrace the commoditization and make money from commoditization, but want it to happen faster. So we've taken a device that probably would cost someone individually to make tens of millions of dollars without even to create individual versions of tens of thousands of dollars, and brought it down to $1,000, and then we will probably bring it down to $100 of BOM. And certainly the goal with this first prototype is not necessarily for it to be the most beautiful, but for it to be something that people can wear, that they can understand this emotional connection, and to start an agenda and a momentum forward in terms of open source hardware that lets people in the community contribute through decentralized mediums, and things like crowdfunding, things like Kickstarter, things like blockchain, to invest in and combine the investment of crowds and the incentives of large companies, small companies, for-profit companies, individuals to solve the monetary problem and to reduce the prices, and then to bring together the combined talents of people to take this prototype, which is incredible in many ways, but also looks like a sort of bug-eyed science fiction headset, and make it small, make it tiny, make it incredible. And so again, we're excited to announce that we will open source this next week, and it's the beginning of a journey of open sourcing, so we'll continue to release new iterations of this, and we'll probably launch things like a dedicated website and dedicated open source portal for Northstar itself, so that eventually the community can take it on its own. So again, I'm much over time, but thanks everyone. It's an incredibly exciting time to be in this space, and it's been great to talk to you. Thank you.